Now, force and thermal stress. Now, we have to set up a relation for the force and thermal stress. But stress is very clearly force per unit area. We are referring to the force which is between the atoms in a wire. And that force is called the interatomic force. So what happens basically when we consider a wire? Now, in the original wire, there are plenty of atoms and they are arranged in three-dimensional repeated pattern. The axis on which the atoms are arranged are called the lattices, and the points where the atoms occupy their position, those are called the lattice points, and the distance among the two atoms when no force is applied is called, that is, interatomic distance, and the force between those atoms will be interatomic force. Now, we have to set up a relation for force and thermal stress. So, whenever we apply force on the wire, we find that there will be a slight increase in the interatomic distance. Similarly, we can take like this, that whenever we consider a wire and we slightly heat it to a particular temperature, then we find that there is variation in area of cross section and length. That is, we take into consideration beta and alpha, that is the linear expansion and the superficial expansion or the area expansion. And the product of two gives the coefficient of volume expansion. So when we heat a wire, the interatomic separation increases. Similarly, when we cool it, the interatomic separation decreases. And we assume that the wires are fixed between the 2 points, that is the 2 clamps. And now we come towards the main concept. When a wire or a rod whose both ends are clamped, means they are fixed, is allowed to cool or warm, a tension is generated in it. In it means among the atoms due to elongation, that is the change in length, or contraction of the wire, that is when we remove the applied force, there will be contraction in the wire because wire's tendency will be to come back to its original position. And this is called the thermal stress. Thermal means regarding heat. That is stress produced due to heat. That whenever we heat, there will be variation in stress, that is the force per unit area. If A is the area of cross section of the wire and L is the length, then the product of A and L will give the volume. L is the length and Y is Young's modulus of elasticity, and Young's modulus is the ratio of stress and strain. A coefficient of linear expansion, that is change in length per degree centigrade rise in temperature. So coefficient of linear expansion and L increase in length due to change of temperature, delta T, that is small temperature change. Then the thermal stress produced and it will be given by composition. Thermal stress is equal to Y into strain. Y means Young's modulus of velocity and multiplied by strain, where Y is stress by strain. If we cancel off strain, we will get thermal stress. So Y into alpha lambda T multiplied by, that is Y into alpha into T2 minus T1, and tensile force. Force means mass into acceleration. So tensile force, that is Y alpha delta T into area, and that can be written as YA and alpha into T2 minus T1, because delta T will be T2 minus T1. That is the change in temperature. Well, now next discussion is regarding the interatomic force constant. As I have cleared earlier, what is interatomic force? That is, if we consider a wire or a rod, it is made up of many atoms. Atoms are arranged in a three-dimensional repeated pattern. The axes on which the atoms are arranged are called the lattices. The distance between the two atoms on lattices, that is on any of the three lattices, that is x-axis, the y-axis, and the z-axis. That distance is called interatomic distance or interatomic separation. And the force between the two atoms in the original position is called the interatomic force. Now, if we apply some heat or if we apply mechanical force, the distance between the atoms increase, and that is called elongation. But when we heat the wire or a rod, again we find there is expansion. But this expansion will be of three types. That is the length expansion, the area expansion, and the volume expansion. So we find that the distance again among the atoms increase or the volume of the wire increase. So we will find that interatomic forces that will decrease among the atoms. And the chances are that at a certain limit, the wire will be totally deformed or rod will be totally deformed. So now we are coming towards certain constants for these interatomic forces. Now the main concept is like this. When an external force is applied on solid, the interatomic distance change. As I have suggested just now, the interatomic distance change, producing an interatomic force. Normally these forces are attractive forces among the wires or the rods. They are called the metallic forces. The interatomic force F0 is proportional to the change in interatomic separation, that is the distance. So delta R. Suppose that the original force or interatomic force is F0 and the change in distance is delta R. Then if we multiply F0 with delta R, that will be the slight or the small work done. So now F is proportional to delta R mathematically, and when we remove the proportionality, we just put a constant here. So F0 is equal to K0 delta R, and K0 will be F0 over delta R. So basically this interatomic constant K0, that is basically the ratio of the original force or the interatomic force and that is the small change in distance. So K0 will be interatomic force divided by the small distance. Force is in Newton, delta R will be in meters. So interatomic force constant is expressed in newtons per meter. If we wanted to estimate the dimension, we have to put the dimension of force, that is MLT minus 2, and it is divided by meter. So we can simplify this and we can get the dimensional equation of K0, that is interatomic force constant. If the Young's modulus for the material is Y and the equilibrium distance between the atoms is R0, then K0 will be equal to Y into R0. That is what the mathematical statement for the interatomic force constant, that is given in terms of Young's modulus velocity and the interatomic separation, that is R0. The forces among the atoms in this situation are called the metallic forces or interatomic forces.